and share and subscribe and like.
Welcome to this new video. In this video, we will discuss about a very important method of partial differential equation, that is a method of separation of variables. Now, this method will be clear by taking one problem. Suppose we want to solve the problem which is you can see on your screen, that is del u by del x equal to 2 into del u by del t plus u, where the initial condition is given u of x comma 0 equal to 6 into e raised to minus 3x. Now you can see that here we will take this u is a function of two variables. Suppose here it is given that u is a function of two variable x and t. So we take this u as a product of two variable, capital X which is a function of x and capital T which is function of t. That means capital X is function of x only, function of x alone. It is function of single variable, single variable. T is function of t alone. T is also function of small t, and it is not a function of x. Okay, and therefore their derivatives, if we take the del u by del x, then this t is a function of t alone, therefore it will remain constant when we differentiate with respect to x, and we have del x by since it is a function of x alone, so it will be the total derivative d capital X by dx, and we write this as a t into x dash. Similarly, del u by del t equal to, here x is function of x and it is in the multiplication, so it remain it as it is, and we have a total derivative since t is a function of capital T is a function of small t, and therefore we have ordinary derivative and we have x into t dash. Now let us put these values here in the given equation, that is del u by del x is equal to what, then t into x dash equal to 2 into capital X into t dash plus what is u, u is x into t. Okay, so here this is how we have this expression. Now let us divide throughout by uh, x into t. Then if we dividing by x into t, dividing by x into t. So if we divide x into t, t get cancel and we have x dash divided by x equal to 2 into x get cancel and we have t dash divided by t plus 1. And suppose we take it as a constant, we equate it as a constant with c. Suppose this value is a c. Then we have two equations, x dash divided by x is equal to c. This is a one equation, and 2 into t dash divided by t plus 1 equal to c. This is an another equation. Okay, so this is an important point to note here, that we have equated the separate variable with constant terms, that is x dash divided by x. When we get a separate variables, separate terms of the variables x and t, we have equated that terms with the constant. Now this is an this if we write explicitly, the equation look like this: 1 divided by capital X d capital X divided by dx equal to c, and this is 2 divided by t into d capital T divided by small t equal to c minus 1. We have taken c to that side. Okay, then here if we integrate, we write this equation as like this: 1 divided by x into dx is equal to c into dx, and integration of this equation gives me log of capital X equal to c into x plus here plus we take here log of a as a constant. Then we have log of x divided by a equal to c into x. Taking exponential, capital X divided by a equal to e raised to cx, or capital X equal to a into e raised to c into x. Okay. Now this is the first one, and second one, what we get here, 1 divided by 2 t into dt equal to c minus 1 divided by 2 into dt. Okay, now again integrating, integration gives log of t equal to 1 by 2 into c minus 1 plus log of b, integrating constant. Then log of capital T divided by B equal to 1 by 2 into C, C minus 1 into T, here integrating constant we get C minus 1 into T. We are integrating this, therefore, so taking exponential, T divided by B equal to e raised to 1 by 2 C minus 1 into T, or capital T equal to b into e raised to 1 by 2 into c minus 1 into t. So this is value of t we get. Okay, but then we have u equal to capital X into capital T. But what is capital X? A into e raised to cx, capital T b into e raised to 1 by 2 c minus 1 into t. This is equal to ab into e raised to cx plus 1 by 2 c minus 1 into t. This is my u. So here, but u satisfies the initial conditions. Look at the initial condition. Now we apply the initial condition to this solution. When we have t equal to 0, when t equal to 0, when t equal to 0, t equal to 0, u equal to 6 into e raised to minus 3x. So substitute u in the solution, t equal to 0. Therefore we have 6 into e raised to minus 3x equal to ab into e raised to cx, right? So this implies that ab equal to 6 and c is equal to minus 3. Substituting this value, we get a equal to 6 into e raised to minus 3x, and c minus 1, minus 3 minus 1, that will be minus 4 by 2, that is minus 2 into t. So we have this solution of this problem. So friend, you have seen that how we have applied the separate variables to solve these problems. Now we will take another problem of this method of separation of variables. Suppose that we want to solve by this expression del 2v, del 2v by del x square equal to del v by del t, and it is given that v equal to 0 when when t tends to infinity, as well as v equal to 0 at x is equal to 0 and x is equal to L. So this is the another problem. Again, we apply the method of separation of variables. Similar technique here we apply as we have applied in the previous example. Uh, we take here this v as a function of two variable, v equal to capital X function of which is function of x alone, and capital Y which is function of t alone. Or then this is a v. Okay, so we take here, this is not capital Y, here we take this is as a t, capital T as a function of t alone, function of t alone. Then del u or del v by del x equal to, this is constant sum, so it remain as it is, and derivative of x with respect to x is x dash. Again del 2v by del x square equal to t into x double dash, del v by del t equal to x constant, and we have t dash. So let us put these values in the given equation. We have t into x double dash is equal to x into t dash. We have substituted this value. Now transfer this x term to this side and this t term to this side. We get x double dash divided by x equal to t dash divided by t. Now separated are variables are separated. Now we equate this with constant minus p square. As we have seen, when variables are separated, we need to equate with constant to get a solution. Therefore, we have an first equation x double dash divided by x equal to minus p square, or this is as d2x by dx square plus p square x equal to 0. It is a second order differential equation, and auxiliary equation of this is m square plus p square equal to 0, m square equal to minus p square, and m equal to plus or minus I into p. So roots are imaginary, and therefore we have capital X equal to C1 into cos of px plus C2 into sine of px. So when the roots are imaginary, their solutions are trigonometric functions, and to know how we have an imaginary solution, you have to watch our videos on the ordinary differential equation. Now second solution of this second equation is t dash divided by t. T dash means 1 divided by t into dt divided by small t is equal to minus p square. Okay, then you can see that here 1 divided by t into dt, 1 divided by t into dt equal to minus p square into dt. Integration of this, log of t equal to minus p square into t plus log of c3, or log of t divided by c3 equal to minus p square t. Taking exponential, t divided by c3 equal to e raised to minus p square t, or t equal to c3 into e raised to minus p square into t. Then v equal to, what is my x? X is a c1 into cos of p1x, so this is a c3 e raised to minus p square t, minus p square t into c1 cos of px plus c2 sine of px. This is the solution of this differential equation, given differential equation. Now we apply the initial conditions. So what is the first condition? X is equal to 0. When x is equal to 0, v is also equal to 0. So put here x is equal to 0 and v equal to 0, x equal to 0, c3 into e raised to minus p square into t. And look at this, when we put x equal to 0, we have here cos of 0. But what is cos of 0? Cos of 0 is a 1 and sine of 0 is equal to 0. Okay, so we have these values. Now you can see that this is equal to 0, but here uh, a into b equal to 0, that means either a equal to 0 or b equal to 0. This is a variable term, and this cannot be equal to 0. So there are only two possibilities, either c3 equal to 0 or c1 equal to 0. But c3 cannot be equal to 0, that will gives us my t equal to 0. So this implies that C1 equal to 0. C1 equal to 0, then equation 2 becomes what we get equation 2? V equal to C1 will be 0, so C2 into C3 into e raised to minus p square t into sine of px. We get this equation number 3. Now again apply the second condition. What is our second condition? X is equal to L. When x is equal to L, when x is equal to L, v equal to 0. So put x is equal to L in the third equation. V equal to C2 into C3 into e raised to minus p square t into sine PL. Again we need to apply algebra. Here C2 and C3, these two constant cannot be equal to 0. Okay, this is variable term, so this is not 0. Then what we have? Sine of PL equal to 0, but sine of n pi is equal to 0. So this gives me therefore n pi equal to p into L, and from this we have p equal to n pi divided by L. Okay, so substitute this value into in 3, therefore equation again 3 becomes, we have, what is the equation number 3? V equal to C2 into C3 into e raised to minus n square pi square divided by L square into 2 into sine of n pi divided by L into x. We have this equation number 4. Now friends, we arrive at the equation number 4. Let us take this value of constant C2 into C3 is equal to Bn, and therefore it will look like Bn into e raised to minus n square pi square divided by L square into t into sine of n pi x divided by L. What is n? N is equal to 1, 2, 3, like this integers. So these are the all solutions for n is equal to 1, n is equal to 2. But we know that all the solution, their summation is also solution. So if we take n is equal to 1 to infinity bn into e raised to minus n square divided by L square into t sine of n pi x divided by L is also, this is a more generalized solution of this problem, and hence we
Hello
have
guys,
this
thank you for
solution
watching
of this
video.
problem.